Okay, so we're going to take a look at a type of integration that hasn't really come up yet, but what we've been doing so far has been integrating expressions with a single base. So for example, integration of x squared dx is just going to simply give us x cubed over 3 plus c. So we've just always been using the power rule for integration, but we haven't really run into more complicated functions. Now, when we work with complicated functions, we need to use integration using substitution, also known as the substitution rule. So when does this come up? Actually, half the battle of doing these questions is even recognizing you have to use substitution. So here's kind of a little tip for you. If you notice that you have a composite function, so a function within a function, and outside of it is a derivative of the inside function, so it's the same degree of the derivative of the inside function. So I know this doesn't maybe make sense a lot right now, but we'll see this in our questions. What we try to do is try to simplify it using substitution. So we try to reduce it to something that we can integrate right off the bat and hope that it just works. So it does require just a little bit of playing around sometimes, and obviously some manipulation. So when solving substitution, here's just some rules, okay? So recognize the proper form. Is the composite function being multiplied by the derivative of the inside function? Do you see that pattern? So if that's the case, we're going to define the inside function as u, and then take the derivative with respect to x. So once we have some sort of substitution, this is what it's going to look like. So I'm just not going to skip through the rules and just give you a question that looks like this. So once again, like, this isn't a single base. Now it's 2x plus 1. So we have to use substitution here because I can't just add 1 to the exponent and then divide by the new exponent. It's just not enough here. It's not actually going to create the antiderivative. So if I take a look at this, this is a composite function. Okay, if I take the derivative of the inside function, I get 2. Now, you don't see 2 here, but that's okay because 2 is a constant. So we see a constant function out front, which is just 1. So what I'm going to do is use substitution. So I'm going to let u be equal to 2x plus 1. So instead of me writing it as 2x plus 1, I'm now going to integrate it so that it's u to the power of 4 dx. But unfortunately, my problem is I can't integrate with respect to x because this is u. So I need to rewrite dx in terms of u instead. So going back to this u equals to 2x plus 1, I'm actually going to create du from here by taking the derivative of both sides with respect to x. So when I do that, I get du dx is equal to 2. Okay, so what's the whole point of that? I can actually find dx by solving for this. So this is weird because we don't usually split this up. We usually just leave it as is, but we're going to split this up. I'm going to bring dx to the other side by multiplying. So I'm going to get du is equal to 2 times dx. Therefore, dx can be rewritten as u as du over 2. So I'm going to actually put this expression back in for dx so that I get an integration with respect to u instead. So u to the power of 4, dx now becomes du over 2. So this right here, I'm going to actually rewrite it like this. I'm going to go integration of u to the power of 4 divided by 2. So I'm just going to bring the 1/2 and just shift it over. And we get du. So I can actually integrate this now with respect to u and then back substitute whatever u was in the beginning. So when I integrate, I get u to the power of 5 over 5 times 2, which gives me 10, okay, plus c. So I wouldn't actually just state this as my final answer because u was originally 2x plus 1. So I'm going to put that back into here and state my final answer. I get 2x plus 1 to the power of 5 over 10 plus c. So that right there is the integral of my function using substitution. So this next question I'm going to do here, I'll do it in the next podcast along with the other one after this one.